BioGeoBEARS. You will get it also if you just search BioGeoBEARS in Google.
Hey, did you set up for? Oh, you were there.
Yeah, we connected and now we are. Yeah. Yeah. So if you search BioGeoBEARS in Google, the first link that comes up is this. You can, it basically summarize a whole bunch of things here, including installation. If you go there, it will give you all the instructions on how to install BioGeoBEARS, the other packages that it needs, all of that. Yeah, so I won't go over this because you can do it in your own time. And if you go further down here, it also has the example files here, which we have already included in the pen drive for you. But this is the same example file that we're going to be working with today. And there is a script. So this is, not everybody is great at coding. I'm not. The only way I was able to use BioGeoBEARS is because all the codes are there. So you modify it for your files and you can have that. And these set of codes run for all the 6 models. So Tech plus J, Diva plus J, and Gray area plus J. So you can go through this too when you're trying it on your own data set. Yeah, so if you have doubts about it, this is where you can go. There are also Google groups on BioGeoBEARS where you can post questions and somebody who's used it will answer it for you. Okay. So what we'll start with is how to code the matrices that you need to run BioGeoBEARS. And there are basically 6 files that you need to run BioGeoBEARS. We'll start first with the tree. So you can run BioGeoBEARS only if you have a dated tree. And the tree has to be in NEWIC format, NEWICK. You can convert your regular, ultrametric tree to NEWIC using Fig tree. I didn't include it, but I'll just quickly go over it if you want on an example tree that I have. Okay. Yeah. Okay, so this is an example time tree that I have. Don't worry about, any of it, but so this, you can tell it's a time tree because it's an ultrametric tree. You go to File and you go to Export Trees. I'll go slowly again. Go to File, Export Trees, and here you can change it to NEWIC. Okay? And you save as currently displayed and say OK. And when you're naming it, you put your name and put NEWICK. Okay, that's the format that BioGeoBEARS reads. So your trees have to be in this format. Okay, that's the first file you need. So in the example files, we've included the tree in NEWIC format, and this is how it will look. Okay, so the dates are there, and this is how the NEWIC format looks. Okay, the second file you need is the geography file, and here is where you code for where the taxa are distributed. So the names in the geography file should be exactly the same, capital, spaces, underscores, exactly the same as the names are on your tree. Okay, and so this here shows the total number of taxa you have. This number is the number of regions you have, the biogeographic regions. You will decide it based on your area that you're looking at and all of that. And these 4 letters are for the 4 areas. So the letter that you give to indicate each area. This is based on Hanske's data set. So I think he's looking at the Hawaiian Islands. So these are the 4 islands that he's looking at. Okay, and they're coded binary. 1 is for present, 0 is for us. And a species can be present in multiple regions. It's not, exclusive to one region. So you can have 1, 1, 0, 0, whatever. But this is having code for whether your taxa is present in that biogeographic region or not. Okay? And another thing to be careful about while coding all of these is try and use a text editor like Notepad Lite. Don't use Notepad because like if you are here and then you add an extra enter somewhere, that's going to create a problem when you run it. It's going to say that the file is incomplete or something like that. So try and use Notepad Lite. What else about this? Any questions about how to code this? No? Okay. Okay. Then you have another file called the time periods file. This is if you're going to do time stratified analysis. And that's basically, your divisions all there in a list. That's all. So you don't have to put the 0. It assumes from 0. And so that would be 1 from 0 to 0.5, then 0.5 to 1.9, 1.9 to 3.7. This is all in million years. So this is where you're breaking up your analysis based on the, time periods that you want to run it in. And that's it. So make sure that there is no enter after the last digit. Your cursor should be right there. Okay. And I know it seems really silly, but when you run it finally, it will show you an error, and then you'll have to go back and do it again. So make sure you do all of these properly. Okay. Then there are the matrices. Okay, so we have a tree file, a geography file, a time periods file if you're going to do time stratified analysis. If you're not going to do a time stratified analysis, you don't need a time periods file. It will run without it. You just remove the code for it from the set of codes. Okay? And okay, now we will start with the area adjacency matrix. So the area adjacency matrix basically goes for whether two areas are adjacent enough for dispersal to happen between them or not. Okay? And the number of matrices here correspond to each time period. So yeah, so we have the time periods here, and so the oldest is at the bottom. So this matrix over here is the 5.1 to 10 million years time period matrix. Okay, and so here is where between 5.1 and 10 million years was island K close enough to island O, and that's coded as 1. Okay. Unfortunately, this matrix is not very informative like we would have in case of India, because these islands haven't moved apart much. Their history hasn't changed in 10 million years. But yeah, this is where you code for whether two biogeographic regions are adjacent enough for dispersal to have happened between them or not. Okay, and yeah. So you can see that the number of time periods here, assuming of course the 0 is not put there, but is the same as the number of matrices in this file. Okay, so you have to make sure that that matches. Otherwise, it's going to say information is missing. And then don't forget the end at the bottom. Okay, and no enter after the end. Is that clear? So this matrix is basically each row is the same as each column. This is A, O, M, and H, but you don't put them. Okay. Any questions? Okay. So that is area adjacency. Now we'll come to areas allowed. Okay. So this is where most of the confusion happens when you try to do BioGeoBEARS. What's the difference between these two? And it's not explained very well, but from a lot of trial and error, we have figured out that area adjacency pertains to the land masses, whether those two land masses are close enough or not. Area allowed is the combination which that species can occupy. So, for example, let's compare the area adjacency and areas allowed. So, in this last matrix, you can see that K and O are adjacent, but it says K and O is 0 in the areas allowed. So what it means is that the two land masses are close enough, but that species can't occupy a combined area of K and O at that time. Okay? So this has to come intuitively based on your understanding of your group and of the land masses. But this is where that slight distinction happens. Anything else about these two matrices that are missing?
No. So I just like to demonstrate it with some drawings.
Oh.
So suppose you have two areas, okay, and they are adjacent to each other for the time period A to B. So then you will code in both in areas allowed matrix, you will code it as 1, and in area adjacency matrix you will code it as 1. Suppose for the next period of time they have separated from each other, but they are still adjacent to each other. So dispersal can happen. So for this time period you will code it as areas allowed. So in the phylogeny it can't reconstruct as a combination of this area in the node, because the species can't occupy those two areas as together. Okay, as they are not together. So in the areas allowed matrix it will be 0, but in area adjacency matrix it will be 1. Suppose for the next period of time they are totally separated and far away from each other. So for that time period, area adjacency and area allowed, it will be both 0. Okay, that's the.
Okay, so since we demonstrated that, there's another point. So two land masses can be far apart, not adjacent to each other, but a species that is very mobile can occupy both land masses at the same time. And that's where you would code area adjacency as 0, but areas allowed as 1. And there BioGeoBEARS will invoke a jump dispersal. Yes? So it will invoke vicariance if it's, at a certain period they are adjacent and they both could, occupy that. Basically the land masses were together and the species could occupy the combination. And then they kind of split. There it will invoke vicariance. So this is how the software sort of distinguishes between vicariance and, J or jump dispersal, is if there are two land masses that are not adjacent, but you are still coding based on your understanding of current distribution that the species could occupy those two land masses, then the only way it could have come about is by dispersal, jump dispersal. So there you will get the jump dispersal in the result. Okay. Again, same number of matrices as the time periods. It will seem like I am, harping on this point, but you can mess up a tiny bit in the coding of the matrices and you will get a whole bunch of errors. And unfortunately, the errors are not very informative. It will show a whole bunch of gibberish and you'll be like, okay, what does this even mean? And the only way you can figure it out is go back, look at your matrices, try and fix something you messed up. So be very careful when you first code the matrices, it will just save you a lot of headache. So those are the two areas allowed and area adjacency matrices. These are all binary. You can't put decimals in here. Okay, it's all 1 and 0s. But the last matrix, which is the dispersal multipliers matrix, here is where you can do all your mischief. He didn't actually do any mischief, he just used 0s and 1s. But from my talk, you remember I coded it as 0.75s and 2.5s, and it can be any value under 1. But what you have to remember is it has to be relative. So, like if dispersal between K and O in this 0 to 0.5 time period is 0.2 is okay. So if K and O are closer together than K and H, and you allow for dispersal between all the islands, then the islands that are closer together will have a higher dispersal probability than the ones further apart, right? So then you can code maybe this as 0.8 and this as 0.4, and that's allowed to. So the dispersal probability multiplier can take decimals. It doesn't have to be 1 and 0s. You can also, this matrix doesn't have to be symmetric. So if you say k to, so this is k, right? So k to O is 0.8, but you don't expect the species to come back to k because there is some value, okay? Then you can put this as 0 or 0.0001. Try not to use zeros in your dispersal multipliers matrix. It says it's over constrained and it won't let you run it. So try and use like a very small number, but put a number there. But yeah, so you can also use it to constrain for unidirectional dispersal. You can make it go one way. It doesn't have to be bidirectional. That's it, no? Okay. So those are all the matrices for BioGeoBEARS. Any questions before we move on with the analysis? No? Yeah, okay. So this runs in our studio. And I've basically just copied that example script from here. So if you go to the BioWiki page, you can click on that and it will take you to the all the codes that you need to run BioGeoBEARS. And you can, go over this in detail. He explains what each of those codes are for, including setting up BioGeoBEARS, all the libraries that you need to recruit to run it, etc. Very detailed notes here. But we'll get started. So these codes have all come from there. Okay. So the first thing you need to do is, after you've installed it and you've got everything running, you need to set your working directory. So you go to Session and go to Set Working Directory, choose Directory, and choose the folder which has all your matrices, trees, etc. Okay. So I have it here, and I'm going to choose that folder. So I've set my working directory. And there's a bunch of codes that you need to run to get all those packages started for BioGeoBEARS to run. That's also included in the example file. And so you just run all of them. I'm just going to run those now. So it's loading the required packages I need to run BioGeoBEARS. Okay. And then I'm going to get my working directory, and I'm going to extract the directory for BioGeoBEARS. Which one? Okay, so first you have to set your working directory. And you do that by going to Session, Set Working Directory, choose Directory. And there you choose the folder which has all your matrices and trees. Okay. And after that you run a bunch of codes which are there in the script file. And those basically loads all the packages that you need to run this analysis. And so when you're installing BioGeoBEARS, all these packages would have been installed. That's the only way it will run. Okay, so I'm just going to run the codes now. Okay, so I got my working directory, I extracted the data. So this is a code to recruit your tree, and make sure that this path is, where your file is. So it's I don't know if I need to go over it, but basically, if you want to get that, you just go to your file, go to properties, and this location, you copy that and you can put it there, but make sure that you make all the backwards slanting arrows as forward, because BioGeoBEARS needs forward slanting arrows. So yeah, so specify the location of each of your files. So this, one second, I'll just make it So that's your trfn is your tree file, geogfn is your geography file, okay? This times fn is your time period file, and this is the dispersal multiplier, this is the areas allowed, and this is the area adjacency. We have 6 files and it's going to load all of these, it's going to recruit all of those 6 from the folder that you have created it in, okay? So you can't mess up any of these because these are all the essential files you need to run this analysis. Okay, so I'm going to run that now. That basically reads the tree file, and now it's put the tree file out there for us to see if we want to. That's the geography file, and the geography file now you can see here. See here, this is the same file that we coded, right? Yeah, so it will also tell you the maximum range size. So you remember the, so for each node it will reconstruct an ancestral area that consists of a combination of areas. And here you can set the maximum range size. This is set as 3. So in any ancestral area, it can't be more than a combination of 3. So in this analysis, there are 4 islands, right? K, O, M, and H. In any of the nodes, it can't have a combination of more than 3 areas. That's what this sets, the maximum range size. Okay? Then that's the time period file. It's now basically just going to put all your matrices out there. Okay, I'm just going to go through that. Yeah, so all your matrices, all your tree, geography, time period files are now all up there. And then you just run BioGeoBEARS, and these are all default settings. You can tweak them around, but none of the analysis that we need generally needs any of these settings to be changed. There are a few more complicated models like deck star model and stuff, which honestly nobody's used so far, but the BioWiki page will explain it, how you need to code for all of that. Yeah, so now it's basically just running all the files that we loaded. So dispersal, the time period, dispersal multiplier, areas allowed, area adjacency. And the next set of codes is just how to optimize the run, the ML search. None of these need changing, or any of the models that BioGeoBEARS uses. Okay. So you see, it says incomplete final line found in all of that. So this is the kind of error you'll get if you've added an extra enter somewhere. So now I have to go back and change. Check all of them. Okay, what happened with this person? So let's see. I have saved it. Now I have to run all of these again. So from here I'm going to reload my matrices and then run it. Yeah. No. Okay. So you do need an enter after end. Don't end it here and save it. You need an enter after end, and then save it. Okay. Read files. Okay, time periods also needs. So now you got to run all the codes again. So this is what I was saying, if you miss one enter, you got to go back and run all the codes again. It doesn't take too long, but it is tedious. all passed. Okay. So when you run the final check, it will say red whatever, and if there are any other problems, it will tell you here. So when you're running BioGeoBEARS, you can run the whole set of codes in one chunk, but try and run it till the check first, because then you'll know if there's any problem with your matrices. And you know, if you clear that first check, you're all good, then it will run very smoothly. Okay, so the next step is to run so it's first going to run the deck model, and then it's going to run the deck plus tree model. So the next set of codes is just to run it, and run. Okay, and then you just got to wait till it's done. Hopefully this won't take too long.
Does it take long otherwise?
9 takes about. Deck plus day takes a little longer, but even deck takes like half an hour.
Because day plus day first runs in it, when it gets the dispersal data from there, it starts running.
Yeah. But we are doing March case data set, so hopefully.
It says that it uses value, it's very fast.
That's the thing, you know.
So you will see. Okay, there you go. Alright. So it's done the first run, which is for deck. Okay, and from here it is going to move on to deck plus day. The results will have both deck and deck plus day. So the next set of codes basically runs deck plus j, but uses the same files. So you don't have to load them again, you just have to. And again, this also has a check. One second. And here is where you add that j parameter. So the default value for j is 0.001, which honestly is enough weightage for j. The d and e parameters it takes from your deck run. Okay. So run that code, and there's another check here. So run it till there to see. What is that? Argument is of 0. Where? Oh yeah, but it ran deck. So yeah. No, and that error is very specific. It will say that you have over constrained your dispersal multiplier. Please go and change the value to 0.001. I have no.
What error in the run? No, above that, I was transferred.
Hey, I mean, it's example data. Oh. Okay. Not open. Nice. It's just the name. I haven't changed. It's a title. It's a capital T and there you go. Yeah. They couldn't have said that. T underscore. You know what?
It doesn't want to adjust. No, you got it. It has to be just perfect.
I mean, that's fine, but it could have just said capital name isn't matching.
Yeah, but they don't want
I don't
that
know what
like
Tim's one means. Okay.
Just take
Yeah,
it.
sorry, I think I didn't change the codes for the deck plus J part. Let's just make sure. Okay. So now all the names match. Capital underscore. Yeah, okay. Let's run it again. Yes. Okay. Okay, and now we run this. So your analysis isn't gonna fail because of anything major. It's mostly gonna fail because you didn't capitalize it in the code or something. If you're good at coding, I'm sure it will be really easy. Take test two. Take this. If there are errors that really baffle you, you can just copy the error as it is and post it on Google, and somewhere in one of the groups somebody would have discussed it, and maybe that will help you make more sense.
Got some time there.
Right, but
So currently, Nextk has come up with the rebuttal on.
Real time one.
Yeah. I've not looked at that YouTube channel yet. So.
But Retro was saying it's because he found one example where deck is better than deck plus J.
So it was a short YouTube video where he's addressing this issue. He was talking about it in a seminar.
Okay.
And that paper is in preprints because it is coming in Journal of Biogeographical. I think within a month it will come out.
Okay.
And then it will become very interesting.
Yeah,
Again, yeah, long argument between two groups.
I mean, I think I agree to the critique to a certain extent that you really need to understand what you're using this for instead of sort of using it default, because it can give you all sorts of really weird results, right? Like our null model.
And wasn't one of the main critique was that the way it is calculated, it is just adding some.
Extra points for J.
Yeah.
And statistically also it makes sense, right? Because it has an extra parameter, so does J. So how do you compare it with a model that has 3 parameters? Comparison should be between equal number of parameters, right? Deck is 3 and plus J will be 1 more.
Yeah. No, but if one can say it's a parameterized model, like models of sequence evolution. But if you're just adding a number to your likelihood instead of actually inferring whatever,
Taking it
including
into
the J as a part of the model,
yeah.
then it's a problem.
But PRC also penalizes for using extra parameters.
Alright, so that run is done, and now the rest of the codes are for how you want your PDF to look like. You can change the width and the height here because sometimes it crunches it up, you can make it wider or whatever.
I don't know if it is incorporated. No, I don't know.
Okay, and it's going to plot both the like the ancestral areas, as well as another one with all the pie charts showing the other probability for other combinations of areas. Yeah. Yeah, and that's the result. So the first one, it has 4 figures. The first one is for debt. All of that right there. This is the log likelihood for this result. Okay, and if you are going to compare multiple debt results, you can use this log likelihood to calculate your AIC value. So that's what the result looks like, and the ancestral areas at all these nodes is the area with the highest probability. But the pie chart will also, this pie chart isn't really, it doesn't give, like here, there is another area that has, less probability than the one that has been inferred, but you will need to present this as in your data, in your results as well.
Yeah, that one is better. The pie chart.
Yeah. Yeah, the pie chart's better because then it's more informative. And yeah, so that was deck, and we have deck plus J. Let's see if anything changed. This part is the same.
There, jump dispersal in here you can see 2 places. 3 places.
Yeah, but this is a deck.
Oh.
Yeah. Yeah. For this analysis, I think they can make the they both get the same result. This is deck plus J. So they're all together. There are 4 files.
Hey, now this is also J equals 0.
No, 0.19.
0. Oh.
Yeah, this is deck plus J. And the first one was deck. But it doesn't seem like there's anything different. Yeah. Log likelihood is good. Log likelihood is better for deck plus J. But I'm just, okay, so here we have a vicariance KO. Let's see what that shows in deck plus J. Yeah, okay, here. Yeah, that's it. Sorry, okay, so in deck, for this node, it invokes vicariance. So it shows you a combination of K and O as the ancestral area, and then one lineage is found in K and the other is in O. But for deck plus J, it shows a jump dispersal from K to O. Yeah?
So, how do you explain if you go back to deck? It looks like a lot of jump dispersals in deck. How do we explain that? On top, for example. This one.
Yeah.
This one. And this.
Yeah, technically, if it has invoked KO here, it should be invoking KO everywhere. Because it doesn't allow for dispersal. No, it allows for dispersal. It allows for dispersal. But
It looks like a jump dispersal. No. In deck, it should look like that KO stuff.
Yeah.
So that's why I'm looking confused with this.
Yeah, and well, this is Oh, you know what? I mean, it must be based on the matrix coded. Yeah. No, this is like it. You get so this is like variance, this is like
Yeah, so here this person is having here K to O and then
basically it's a range expansion and
Yeah.
then
and variance.
variance.
But this would be junk. So that's why I'm really yeah, maybe the
I think what happens here is for these time periods, actually they're all the same time period too, which is why it's slightly weird. It should between this time period, if it's the area allowed, if we didn't allow for the combination, then dispersal could happen even in day. But this is the same time period, so if it invokes KO here, it should be invoking KO here as well. The other explanation is based on the number of tips. Because it's ML, it does take the number of tips into consideration. So here there are a lot of O's and a lot of K's. And so it invokes a KO here. But here there's only one. So, yeah. But yeah, so the difference, I mean, it's not really really neat, but the difference you can see here in the lower.
Okay, just one thing. Based on the same data set, he got a different output.
Wow.
So it is showing jump dispersal there, but it is not showing jump dispersal.
It is like,
Yeah.
Yeah.
okay.
no, but maybe you use the exact same parameters as
It's like we run with the same example data set, right?
no, but the dispersal multipliers and adjacency matrices,
Yeah.
all of that has to be exact.
Same. So where is it showing jump dispersal?
So at the topmost node, it is showing a jump dispersal there, but it is not showing here.
That is showing as KO.
No, only K. Only K.
That is jump dispersal.
No, just K. So later it has dispersed.
But you change some values for giving.
But I didn't save it. No, I didn't save it. I
And
can
also
check.
estimation of the values for the parameters are also different.
No.
Hey, actually this looks more, yeah, this looks more.
Yeah. Okay.
So what's happened is, see, there's no jump dispersal here.
Did you change any dispersal?
No. So the D value.
So all of
D
these are
value
dispersals, but it's not jump dispersal.
Yeah.
Right? And here also.
Yeah, that's better.
So absolutely not just jump dispersal. I don't know why it's like this.
But also the estimation of the arrows,
Huh.
what's same.
Not the same. Yeah. But that, I guess it just takes from the first run. So.
Hey, there is a difference. 4 areas. 4 areas max. There's
Oh,
3.
yeah.
Oh, I think I didn't change that.
Ah, yes. But we can get a better result.
Okay.
Wait, what is the likelihood?
So the difference was that she allowed
Minus
for 4, the maximum range size, I set it
That
to
is
3, she
better.
set it to 4. Yeah, I was like, I don't know why that should change the results though, because either way it's invoking only one area.
Yeah. So this program, you have to really run it many times before, I don't know, I think Jinta, you must have ran it for like
3 years.
3-4 months you tried different
Yeah,
combinations,
before.
tweaking it. Because see, all these programs, if you don't parameterize the parameters properly, it's just garbage in and garbage out. So you need to play with it and you know, if you give some very unlikely dispersal possibilities, the program doesn't know. It will just show you, give you some output.
Like if you give a very high jump dispersal probability where we give 0.001, it might invoke jump dispersal for everything.
Everything. Yeah.
So
So you think the jump dispersal probability here was too high?
no, it was pretty low.
Anyway, it's not better to look at this more closely
Yeah.
and see why this is.
That is actually just interesting.
But well, this is at least a brief on how, to get you started on coding your matrices, and because that is the tough part, understanding how to code your matrices, what each matrix means, and hopefully that's clear. And then you just got to play around with it till you figure out how to do it.
Yeah, so basically jump dispersal is this situation here where from K, there has been a jump dispersal to another area. Whereas here, it's taken a long time to go from K to O. Right? Remember, I contrasted jump dispersal and regular dispersal. So in the back model, this is what we should see. So this should have happened here, but it's showing a jump dispersal, which is really weird. And it's doing that here also. I know something's funky
Yeah,
about this.
something.
Yeah.
That is the thing, you should not blindly trust the results.
Yeah. Try to understand what it's done, and then go back and play the parameters. You're not massaging the data set here. The data set is the same, right? But maybe internally some of these matrices that you have provided, they're not consistent with each other. That's when you start getting all these weird results. So you just have to go back and look at it again.
And when you code your matrices, code it based on your understanding of the dispersal ability of the group, or understanding of the geological history of the landmass, not based on what you expect your results to look like. So be very objective while coding your matrices and then run it, and hopefully the results will make sense.
Takes a little while to get used to it.
Yeah, but it can do a lot more than Lagrange or any of the older softwares can. So it's a really good tool if you know how to use it.
Okay.
We're done. I can do that.
Any questions regarding BioGeoBEARS? So you can also compare two likelihood scores for different sort of models, and then pick the one that's the best. You talked about that.
Yes, I talked in my talk, and yeah, this is where the likelihood comes.
Okay, so you want to?
Yeah. So all of you have downloaded RASP?
Yes. Huh? Those of you who are able to open it,
Okay. So I think we gave you a link for downloading RASP. And for many of you, that link is not working. So just copy that link and paste it separately in your browser, and then try.
Set up your laptop.
And there